welcome to the concepts video on circles. So something kind of ironic is that we're not going to start talking about circles, but we're going to start off talking about triangles. So isn't that fun? But anyway, so what we're going to do is actually just review the Pythagorean theorem for a little bit. Pythagorean theorem. Okay, so the theorem of Pythagoras said this: if we have a right triangle, and specifically a right triangle, so it has to have a 90-degree angle in it, and we have our side lengths A and B, and hypotenuse length of C, then the following formula holds. C squared is equal to A squared plus a B squared. Okay, so this is just saying that our hypotenuse, and which I'll abbreviate HYP, hypotenuse squared is equal to the sum of the squares of the side lengths. Squares of side lengths. Okay? Lengths. There we go. Alright, so that's kind of just a brief overview of what the Pythagorean theorem says. Okay? So now let's do an example of this, just because practicing is good. Alrighty, so here's our example. It says find the distance between the points -3, 2 and 2, 5. So you might be thinking, wait, whoa, I thought we were just going to do the Pythagorean theorem and like plug in sides and a hypotenuse and then that's it. This is exactly the same thing. Well, not exactly, but very applicable, because the distance between 2 points can be represented as some kind of application of the Pythagorean theorem, and I'll show you how. So let's say we graph these 2 points. All right, so let's just do normal graphing of coordinate points here. So we have 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 3. Okay, so let's graph -3, 2 is over here. Okay, so this is -3, 2, and then we have 2, 5, so all the way up here. Alrighty, so this is 2, 5. So if we want to find the distance between these 2 points, let me draw a line from one to the other, because that would represent the distance, right? So the length of this line here is the distance. Okay, so I'll call it D for distance. And if we wanted to, just because it seems logical, right, we can draw a line straight down, and we can draw a line horizontally across as well. Okay, and this, even though the picture might not convey that, this is a right angle right here. Okay, so see how just drawing the vertical line and the horizontal line there, that we created a right triangle. Okay, so the thing is, the side length of this vertical line here is the difference in y values of our 2 points. Okay, so this is really important. So this is the difference in y values of our 2 points. Okay, so this is kind of like saying y2 minus y1 or something like that. Whereas the horizontal distance, the length of this leg of our triangle, is given by the difference in x values of our 2 points, which could be represented by something like x2 minus x1 or something like that. Okay, so in order to find our d, so then we would have d squared is equal to, according to the Pythagorean theorem, d squared is equal to side length 1. Okay, so like, let's just say s1, which is this side length, s1 squared plus s2 squared. So the side length of this guy squared, right? Because those are the legs of our triangle. Okay, so the thing is, what is the difference in y values? So that would be, according to our points, 5 is the y value of this top one, and 2 is the y value of this one. So we just have 5 minus 2. So that's equal to a 3. So we can plug in a 3 here. Okay, and now let's find out S2. So that'd be the difference in x values. So if we look at x values, we have 2, okay, and then minus a minus 3. So that would be 2 plus 3, which gives us a 5. Alrighty, and then we have d squared here. So on the right side, we just get 9 plus a 25, which is equal to 34. Okay, so d squared is equal to 34, which means that d has to equal a positive square root of 34. So that problem kind of leads us to the distance formula. Okay, so the distance formula. All right, so what is the distance formula? The distance formula is given by, if we're trying to find the distance between 2 points, let's say x1, y1, and x2, y2. Right? If we're trying to find the distance in between these 2 points, it would be given by this formula. D is equal to the square root of x squared minus, x2 minus x1 squared, there we go, plus y2 minus y1 and then quantity squared. Okay? So it doesn't really, this whole thing, that's why it was good to show the previous example first, because this just says, okay, we're taking the difference in x values of these 2 points and squaring it, and then adding it to the difference in y values between our 2 points and squaring that. And then you just square root the whole thing according to the Pythagorean theorem, right? So, and it's also important to note that, so here's a little note, it doesn't matter in which order you subtract. Well, okay, maybe I should make it a little bit more specific. Doesn't matter which point is x1 and y1, x1 and y1, or x2, y2. And the reason being is that even though we're taking the difference and subtracting things, that quantity is going to end up being squared anyways. So it's just going to turn positive anyways. And the same thing for the y's as well. Okay? Okay, so enough about triangles. Now let's start with circles. Okay, let's say we have a circle, and I'm going to try my darndest to try to make a circular object. Okay, that was pretty good. So let's say we have a circle, and then let's say it's, if we're looking on the xy plane, let's say its center is at some point, let's call it HK, okay? And then the radius is right here, and we'll just call it R for now. We don't know exactly how long that is or not, okay? And then, yeah, so that's pretty much it. We could just say explicitly the center is at the point H, comma, K, where H is our X coordinate and K is the Y coordinate of our center. And we also have a radius of R. Radius of R. Okay, so let's just go back. And what defines a circle? That means that from the center, all of the points on your circle are an R distance away, are the constant distance away from the center, right? So that means that R is constant, our radius is constant for a circle, or on a circle, on any given circle, okay? So that also means that the distance from center to any point, I'll just write a little star here. So distance from the center to any point on your circle, is a constant as well, because that's basically just rephrasing what a radius is, right? Is a constant. Okay. So let's say we have an xy point, okay? So this is just an arbitrary point on our circle, okay? So xy is a point on our circle, point on the circle. So we can say that, well, for any point on our circle, xy, it should be a fixed distance, a constant distance from our center, which is given by hk, right? So the distance in between there is denoted by an r. So this is like our distance. I'll just write it in parentheses here. So our r, our distance, should be the same all the way around. So, and again, we're going to implement our distance formula, right? Which tells us we could just take the x values, the difference in the x values, and square it, and add it to the difference in the y values, and square that as well, okay? So again, just to rephrase this formula in actual like English words, our radius, which gives you the distance between the center and any point on the circle, is given by this formula here, okay? So if we just kind of rephrase this in a little way, I'll show you on the next slide what our equation of a circle looks like. So we had r is equal to the square root of x minus h squared plus y minus k squared. Okay, and then if we just square both sides, we're just going to make a little edit here. Okay, so then we get r squared is equal to x minus h quantity squared plus y minus k quantity squared. And there it is. The thing that I'm putting brackets around is called the standard equation. Standard equation for a circle, okay? Alrighty, where r, again, r is equal to our radius of the circle, and hk is the xy point of our center,